Hello everyone, in this video we will discuss shortly the Newton-Leibniz rule. So what is Newton-Leibniz rule? Let us have one integral whose upper and lower limits are also the function of some variable, let's say x. So it is the integral, let's say the lower limit be g of x and upper limit be h of x. And the integrand means which we have to integrate, that is f of x with respect to x dx. So we need to differentiate this integral with respect to the variable. What is the variable? X. So d by dx. So that will be equal to f of, put the upper limit over here, that is h of x, and get the differentiation of this upper limit, that is h dash of x, minus get the lower limit over here, that is f of g of x, that is composition of function, and derivative of the lower limit, that is g dash of x. This is the simple rule for Newton-Leibniz. So whenever we have to differentiate the integral whose upper and lower limits are also the function of x, then just put the upper limit and derivative of the upper limit minus just put the lower limit composition of function into derivative of the lower limit. So let us take one example question. So example problem is like that limit x tending to 0, the upper limit is, let's say 0 to t ln is natural log whose base is e is 2.718281828, 1 plus t divided by 1 plus t raised to power 4 divided by x cube and here dt. So it is in the 0 by 0 form, it is in the 0 to x over here, 0 to x, that is function of x. So here upper limit is 0, okay, the upper function numerator is 0, like when you have to put their x equal to 0, so upper and lower limits are equal. When upper and lower limits are equal, then value of the integral would be 0, so the numerator is 0 and put x as 0, so denominator will be 0, so it is in the 0 by 0 form. When it is in 0 by 0 form, we can apply the L'Hopital rule or LH rule. What LH rule says? That's derivative of the numerator divided by derivative of the denominator until the indeterminate form reappears, until the indeterminate form get vanished. So limit x tending to 0. So we need to differentiate the numerator part, differentiate the integral by using Newton-Leibniz rule. So according to this rule, put the upper limit, that is function of x in this. So put x in place of t, so x ln 1 plus x divided by 1 plus x raised to power 4 into derivative of the upper limit, that is derivative of x is 1, minus put lower limit, that is 0, so 0 always it is 0 and derivative of 0 is always 0, divided by derivative of the denominator, that is 3x square. So x cancel out. Why? Because x tending to 0, but x is not equal to 0. X tending to 0 means x is not equal to 0, that's why we can cancel. So limit x tending to 0 ln 1 plus x divided by 3x into limit x tending to 0 1 by 1 plus x raised to power 4. So it is the standard limit. This part, that is ln x tending to, limit x tending to 0 ln 1 plus x by x, that is 1. So 1 by 3 into 1 by 1 plus put x as 0, 0 raised to power 4. Okay, so here it is 1 plus x raised to power 4. So 1 by 3 multiplied by 1 by 1, so answer would be 1 by 3. So 1 by 3 is our desired answer. I hope you understood this Newton-Leibniz rule application and Newton-Leibniz rule. Okay, thank you.